From the patterns derived from the first principle, we realize that we can actually come up with simple derivative rules, and these rules only work in this form. When you are finding the derivative of a variable, okay, in this case I will simply find the derivative of f of x, which is equals to x to exponent of n. Now you just apply simple derivative rule, which was derived obviously from the first principle. You will simply take this exponent n and multiply it with the coefficient of the variable which you are finding the derivative with respect to. Now the coefficient of this variable which we are actually finding the derivative with respect to is 1. So you will simply take n and multiply it by 1, but from n you just minus 1. So from the exponent you will always minus 1. This is the pattern that was derived, that we realized when we actually were finding a derivative using the first principle. Okay, so basically we're going to be using this formula simply to find the gradient of a tangent of the line. Alright, so basically we're going to be using this simple derivative rule, differentiation rule. Here's an example here. We are finding the derivative of f of x. So we are finding the derivative with respect to x. So you will simply check what the coefficient of x is. In this case it is 1. And what is the exponent of x? It is 5. So take the coefficient and multiply it by the exponent of x. And then from the exponent of x you will simply minus 1. Please note that we are finding the derivative with respect to x. So basically anything that doesn't have x in it, any term that doesn't have x, you regard it or you consider it to be a constant. Okay, even if I have x plus y, x to the exponent 5 plus y, the derivative of y will simply be equal to 0. Okay, when we are finding the derivative with respect to x, everything becomes 0. The derivative of a constant is simply 0. Okay, so any term that doesn't have the variable which we are differentiating with respect to, you consider that to be a constant. Now in this case, this is what you will get, which is 5x to exponent 4. We're going to be using the same rules, but now we are finding the derivative of 2 over x to exponent 5. Guys, there's a problem here because that x to exponent 5 is in the denominator, so take it up to the numerator. Please note that when you take this x up to the numerator, it goes up with its exponent. And you need to understand, guys, whenever an exponent jumps the division sign, whether it's going to the bottom or to the top, whenever the exponent jumps the division sign, its sign will change. Okay, in this case the exponent of x is 5, meaning that if I take x to the numerator, that exponent sign will change from being positive 5 to be negative 5. Now you can apply the derivative rule. And this will give you minus 10 x to the exponent minus 5 minus 1. Minus 5 minus 1 will give you minus 6. Now a lot of question papers will tell you that you need to leave your exponent as a positive. Now in this case, obviously, since 6 is negative, you're just going to take it from, remember this expression, guys, you can simply say this is the whole thing. It is simply divided by 1. So this x and the exponent move from the numerator to the denominator. That is the only way we can make sure that this negative 6 becomes positive. And immediately, remember I told you earlier on that whenever a variable jumps the division sign, its exponent will change signs. If it was negative, it will be positive. If it was positive, it will be negative. Now I took these activities from your classroom mathematics textbook. I'm just going to find a derivative of y with respect to x. Now in this case I have x cubed minus 4x squared plus 6x. So basically that 5, because it doesn't have the variable which we are differentiating with respect to, which is x, so this 5 will simply be equal to 0. The derivative of a constant is 0, okay? As long a constant, it's any term that doesn't have the variable which we are differentiating with respect to. Now you can write this as, especially when it's written as y is equals to something, you can write it as dy over dx, or you can simply write it as y prime. And in this case, obviously, as I showed you in my red ink, I multiplied 3 with 1, it gave me 3, and from 3 I minus 1, it gave me 2. And I multiplied, in the second term, I multiplied 2 with 4, it gave me 8, but from 2 I minused 1, and it gave me x to the exponent of 1. And the third term, because I only had x, I knew that the exponent of x is 1, so I multiplied that 1 with 6, but I minused 1 with 1. Note that I'm going to be left with x to the exponent of 0, and x to the exponent of 0 is just 1. For 5, the derivative is equal to 0, so that is why I didn't even bother to write it. What about here? Now you will end up having g prime g prime t. Here we are differentiating with respect to t. G prime t will simply be, the derivative of g at t will simply be negative 3, and then you're going to have t to the exponent of minus 3 minus 1, and the derivative of 2 is 0. And the third term, the derivative will be 12 t to the exponent of 3 minus 1. And 3 minus 1 is simply 2, and minus 3 minus 1 is minus 4. However, you will realize that our exponent is negative here, so I have to take this t to the denominator. Please note that t will go to the denominator with its exponent, except that that exponent, negative 4, will change and become positive. Now this is exactly the same thing. We're simply finding the derivative, but we're finding the derivative with respect to v. Now all I did was just to multiply 2 with 3 over 4. 2 times 3 over 4 will give me 3 over 2, and I simply minus 1 from 2, so I'll be left with v to the exponent 1. And here I have 1 because it's v and there was no exponent written, so the exponent will be 1. 1 times a half is half, but I'll have v to the exponent of 0 because 1 minus 1 is 0. The derivative of a constant is equals to 0. This doesn't have the variable we are differentiating with respect to. That is why it will be equal to 0. Over there, I'm going to have minus 1 times minus 2. It will be plus 2, but from that minus 1, I minus 1. So I'll be left with v to the exponent of minus 2. That v must go to that denominator with its exponent because the exponent is negative. Now it changes to be positive. Now, later on, when you do your first year, you will learn more about the quotient rule and the product rule when it comes to differentiation. But for now, guys, you have no idea what is going on. So whenever you see brackets, get rid of those brackets. We cannot differentiate when we have brackets or when we have fractions. So get rid of that bracket or simplify that fraction. In this case, you have to get rid of that bracket. I just need to emphasize something. Please note that after I found the derivative, I simply put in the equal sign. So I'm simply saying the derivative is equals to what I found there, right? So make sure you get rid of that d all over dv, which is simply d all over dv will simply be on the left hand side. Okay, now the same way here, we're simply finding the derivative with respect to u, right? So basically anything that doesn't have u will be a constant. Any term that doesn't have u will be a constant. Break the bracket using form. And this is what you will get. Please note that d all over du is still there. All right, now you realize as well that this u exponent of 0 is 1 minus 1 is 0, so I'll be left with minus u squared plus u to the exponent of minus 2. And this is what you will have. Okay, so what I'm going to do is simply differentiate. So 2 times 1 will be 2, and from that 2 I will minus 1, and 2 times positive 1 will be minus 2. From that 2 I will minus 1, so I'll be left with negative 2u minus 2u to the exponent of minus 3. Please note that minus 3 isn't supposed to be there. It's supposed to be positive, so I'm going to take u to the denominator and I'll be left with this. Now you'll realize that here we have fractions. We cannot differentiate when we have fractions, so you'll have to take those out in the numerator, out of the numerator. We'll accept that sign of the will change. Okay, that will change, so that's what you're going to be having. And now you get the and apply to the the derivative of it is now this is also another way of apply this with 3. You can minus 1 from that. 3 times 3 over 2 is 9 over 2, and then when you minus 3 over 2, when you minus from 3 over 2, you will be left with a half. Okay. A half times 3 will be 3 over 2, and a half minus 1 will be half. Minus a half times 6 will give you minus 3, and a half minus 1 will give you minus 3 over 2. And hence you have that. Please note that a half, when an exponent is a half, you can simply turn that whole term or expression and write it in Z form. So basically, if you have x to the exponent of a half, it is the same as finding the square root of x. I still have the 3 over 2, but this x, because half is negative, I'm going to take it to the denominator. That's why you see square root of x over there. It's because I took x to the exponent of a half to the denominator. Similarly here, I took this x to the exponent of 3 over 2 to the denominator. Please note that if the denominator of your fraction is 2, it simply means that it is simply the square root of that expression. In this case, it is the square root of x to the exponent of 3, because that 2 represents the square root, and the numerator 3 represents the exponent of the variable. In this case, the variable is x. And this is the solution for you. You're going to apply the same thing here. You're going to take this and multiply it by 1. From there to minus 1. The derivative here will be, it'll simply be 1 basically, because theta to the exponent of 0 is just 1. Here you're going to have plus square root of 2, but you're going to minus 1 from that. And this is what you're left with. Here, obviously, you can tell that you need to take that to the numerator. That 2 will change and become negative. Now you can start applying the derivative rules, okay? I was rushing there, I don't know why. So basically, this is the step. What you need to do is to write it in this form first. And that's what you will get, okay? I'm just going to explain the basics here because I seem to be repeating the same thing over and over again. In this case, you'll realize that in the numerator you have a binomial, but that binomial is raised to a monomial, which is your denominator, which is just 5x to the exponent 3. What you need to do is to give each numerator its own denominator. The sign remains, it doesn't change. All you're doing is simply to split the fraction and give each numerator its own denominator. Remember, they share that 5x to the exponent of 3, so give each one its own denominator. Basically, we're just going a step before we got to simplifying this. When the denominators are the same, you just represent both numerators as in one denominator. But now we're going back, we want those denominators that are the same. We're simply splitting it, and this is what we're going to have. And then from here, you know that that x to the exponent of 3 can't be in the denominator, so take it to the numerator. So here, when you divide x with x, so over there I still have x, but from that 2 I will simply subtract 3. And over here, obviously, when you move this x to the numerator, that 3 will just change and become negative. And then you just apply the exponential rules that I've taught you. So you will simply say this times that is negative 2 over 3, and then you minus 1 from that. Negative 3 times negative 3 over 5 is positive 9 over 5, and then you minus 1 from minus 3, it will be minus 4, and you can't leave that as a negative exponent, so you will just simplify it that way. Okay, now moving right along. Here you do exactly what I've just done in the previous example. Split it, give each numerator its own denominator, and you just apply what I applied in the previous example. Here it's quite easy. Next thing, we're going to be doing tangent to a curve at a point on the curve, and then we're going to be plotting cubic functions.